The next topic we're going to talk about in Chapter 5 is indirect proof. I don't know that it has anything to do with triangles necessarily in relationships, but it's a topic that is a different way to prove things. We'll use it some. It's interesting because when you talk about indirect proof, we're sort of coming at it at an angle, a little bit different angle. Direct proof is we're going to given a hypothesis or some givens that we know to be true, then we're to prove a conclusion. Indirect proof, we're also going to be given an hypothesis and we want to prove a conclusion is true, but we're going to come at it a little bit differently. Okay? So when we talk about indirect proofs, what we're going to do is step one is we're going to assume that the conclusion is false. Instead of trying to prove that the conclusion is true, we're going to try to prove that it is false. Okay? Sort of coming at it backwards. Then, once we state the conclusion is false, then we want to show that step one leads to a contradiction of the hypothesis or some other fact. In other words, because we assume that the conclusion is false, that the conclusion is false, then the hypothesis doesn't hold. Well, the hypothesis, we know that's given to you. You don't have a choice on whether or not that's true. So if we can show that the conclusion contradicts what the hypothesis says, or what a definition we know is, or what a postulate or theorem says, then step three, if the assumption contradicts a hypothesis or some other known fact, then the assumption has to be false, and therefore the original conclusion must be true. So we're sort of coming at things backwards. In order to prove that something is true, first of all, we're going to prove that it's not false. Okay? We're going to assume that it's false and then show that because it's false, the false assumption can't be true. Therefore, the original conclusion has to be true. Okay? Now, what we're going to do is we're going to show you how to set this up. Follow these steps. These steps are very important. Number one, assume the conclusion is false. Number two, show that step one leads to a contradiction. Because we assume the conclusion is false, then there's a contradiction of the hypothesis. We have a collision, it doesn't work. Or some other fact, like a definition, postulate, theorem. Then point out that the assumption has to be false. Therefore, the original conclusion must be true. Alright, let's look at some samples of how to set this up. Okay, let's see how we set up a step one, and that is that we assume the conclusion is false. So, let's take a if-then, a conditional statement. This right here is the hypothesis. This right here is the conclusion. So we want to assume that this is false. How do we make this false? Two ways. X is not greater than 7, or X is smaller than or equal to 7. Either way. Okay? For all real numbers, if A plus B is greater than C, then A minus, whoa, I don't think that's true. Let's go back and check that out and make sure we got that right. Then A is, okay, that's correct. A is greater than C minus B. Well, this is what we're interested in. We want to show that the conclusion, which is the then, is false. How do we say that's false? Well, we can say A is not greater than C minus B, or we can say that A is less than or equal to C minus B. Either one of those will work. Make sure, if you're doing with an equality and you want to do it this way, that you get that equality in there. Otherwise, it won't be true. We've got another one. If the measure of angle A is 90 degrees, then the measure of angle B equals 45. How would we do that? this is a conclusion. So we would say measure of angle B not equal to 45 degrees. Okay? Now, the last one we're going to look at is if segment AV is not congruent, that's what that means, congruent with a slash through it, is not congruent to segment FE, or VE, then triangle AVE is not isosceles. So what we want to do is we want to look at this right here, which is our conclusion for that statement, and how we're going to say it. Well, pretty easy. Negate what is here. Well, it's already negative, Coach. What can we do now? Negate it. If we negate a negative, we make it positive. So, triangle AVE is isosceles. Okay? That's how we would negate this conclusion. Alright, those are samples of how you would set up step one. Assume the conclusion is false. Is how we set it up. If you can't set this up, it's sort of hard to use. So it's important that you know how to set this up. Some examples of how to set up an indirect proof. Okay, now let's take this and use it to actually do a proof. We're given that 2x minus 3 is greater than 7, and use that to prove that x must be greater than 5. So, step one on the indirect proof is to assume that the conclusion is false. Two ways. We can say that x is not greater than 5, or x is less than or equal to 5. Either one will work. Well, I'm going to choose to say on step 2, we're going to take the assumption that x is equal to 5, and we're going to put it into the equation. When we put it into the equation, 2 times 5 minus 3 is greater than 7, the inequality. Then we have 10 minus 3 is greater than 7, or 7 is greater than 7. 7 is equal to 7, but 7 is not greater than 7. Okay? So step 2 simply proves that the assumption we made about the conclusion in step 1 is false. Therefore, in step 3, step 1 is false. Therefore, the original conclusion must be true. X must be greater than 5. Okay? Very simple algebraic proof of an inequality using indirect proof. Okay, now let's use this indirect proof stuff on an actual geometric proof that we want to do. Here's what we want to do. We want to show that given that angle 1 is congruent to angle 2, prove that DG is not congruent to FG, and given that DG is not congruent to FG, then prove that DE is not congruent to FE. So here's our picture. We've got two triangles here. They have a congruent angle, and then they share a side, okay? And that's what we're supposed to prove. No, this is our hypothesis, and this is our conclusion. So step 1 on the indirect proof is to take the conclusion and assume it's false. Well, how do we assume that DE, segment DE, is not congruent to segment FE? Well, we simply say they are congruent. Okay? So segment DE is congruent to FE. Now, what's our step 2? We're going to run through a formal proof, okay, and see where it leads us. We're given that, what? Angle 1 is congruent to angle 2. That's given. We know that EG is congruent to EG because of the reflexive step. And we're going to take that thing right there and stick it in here because that's part of our indirect proof that we're using to prove that indirect stuff. So we're going to say that segment DE is congruent to FE. That's our step 1 assumption right there. Now, because we're using these things, we can say triangle DEG is congruent to triangle FEG. Why? Because of SAS. Side equals side. Oh, you mean we're going to go back and pick up that stuff? Yes, you are responsible for everything you've been exposed to since the beginning of the year. Then we can come down here and say, step 5, well then that means that segment DG is congruent to segment FG because the CP, CTC. Corresponding parts of congruent triangles are congruent. Okay? Now, let's go to step 3. That's our proof. Step 3. Statement number 5 contradicts the hypothesis. Right there. The hypothesis states, you can't take exception with it. The hypothesis states that segment DG is not congruent with segment FG. Our proof using this statement and our number 1 assumption says that DG, segment DG, is congruent to segment FG. Therefore, because our proof using the assumption is a contradiction to our given hypothesis, then the original conclusion must be true. So let's change this. This should actually say what? Then DE is not congruent to FE. Okay? In indirect proof, using a formal geometric proof, okay, to prove that the original conclusion is true. Indirect proof is interesting. A little story that I tell. Maybe I'll record it and y'all can listen to it.